Hey guys, I want to do the answers for problem 3.2 and 3.8 later. Let's do 3.2 right now. So basically this is the first time where we've allowed the individual to have more money that's not just wage money or working money. So it's going to make the budget constraint look slightly differently. Alright, so now we have the individual, we have leisure right here, leisure. We have consumption like normal, and furthermore, now you have 60 hours of leisure, which, so cap L is 60 hours of leisure. You also have $300 trust fund. So what's that going to do to your endowment point? Well, if you sit and do nothing, you'll still have the 60 hours of leisure, but the endowment point won't be on the x-axis here. It will actually be up at 60, 300. So here's your endowment point at 60, 300, okay? And then finally, in order to actually draw the budget constraint, we have to ask, well, at a $20 wage, what does it look like? And remember, every hour you go to the left, you're giving up an hour of leisure, which means you're working for 1 hour, so that means you're gaining more money in income. What's the maximum amount that you could eat? Well, if you took your 60 hours of leisure and multiplied it by the slope is equal to the wage, which is equal to negative 20, or just 20, then that 60 times 20 is $1,200, plus the $300 down here from your trust fund, and you get a total of $1,500. Okay, so this is your budget constraint. Your choice set is actually everything underneath this this four-sided shape quadrilateral right here. Okay, where is your endowment bundle? Well, that one's actually here. It's at 60, 300, and I've labeled it E right here. Next, how does your graph change when your wage falls to $10? Well, so this is actually not too bad. We know when the wage falls, the opportunity cost of leisure goes down. So we know we must have a slope that gets closer to 0, because this, remember, flat would be a 0 slope. So it's going to rotate, and where does it rotate around? Well, it always rotates around the endowment point. So basically it would just look like this. The new slope is now 10 or negative 10, and the maximum amount now that you could eat would be 60 times 10, that's 600, plus 300 is 900, okay? And so that's what happens if your graph, if you drop down to $10 an hour, it rotates inward around the endowment point. Part D of 3.2a says, how does the graph change if instead the trust fund gets rated by your parents? Bummer, leaving you with only $100. So let me erase this actually. So it says instead, so the key here to realize is that the $10 wage thing, that's going away. I'm back to my $20 wage thing. Now, really, the slope is going to stay the same. The only thing that changes is my endowment point. So instead of being at 60, 300, it's going to be at 60, 100. It's going to have the same slope. Okay, and now if you think about it, it's going to, my maximum amount is 60 times 20 is $1,200, plus $100 for the trust fund. It's going to maximum be able to go up to $1,300. Okay, and so that's graphically how this happens. The part B says, how would you write your budget constraint? Well, we can write it formally. The budget constraint is a function of what are my exogenous variables, W and L, and it is a set of consumption and leisure. That's in R2, positive quadrant, such that, now I don't have room here so I'm going to write it down here, such that usually, what do we have? Let's write it out long, and then we'll shorten it down a little bit. We usually have consumption is equal to my income. my income is going to be wage times my total amount of labor hours minus my leisure hours. This term right here is how many labor hours. So wage times my labor hours, that's my amount of labor income. Usually we've been leaving it there. Now we have this additional $300. Okay? This part actually I want you to keep simplifying it a little bit more, so I'm just going to rewrite this part instead of rewriting the whole thing. So consumption is equal to, well, I actually know my wage is $20 an hour. I know cap L, it's $60 an hour, minus leisure, plus 300. Consumption is equal to, that's 1,200. So that's 1,200 minus, this is 20 times leisure, minus 20L. Alright, plus 300 implies that consumption is equal to 1,500 minus 20 leisure. Now that's your budget constraint, with the exception of one thing. Notice, can I actually keep consuming all the way down to this point? No, actually those are not on my budget constraint, even though they are technically on this line. So I should also put a thing that says, by the way, leisure has to be less than or equal to 60. Okay? And this right here, it would be the appropriate constraints. So if you want to take these and plug them into the right-hand side there, that will give you the appropriate budget constraint. Alright, now 3.8. So we have an intertemporal budget constraint that we're drawing between two times. And so an intertemporal constraint always has consumption now, consumption then in the second period on the vertical axis like that. Okay, so the thing that's different in this example is that you have two different interest rates. So you have to figure out which interest rate corresponds to which location. First, let's start with the endowment point. So just as we usually do, we have 5,000 this summer and 5,500 next summer. So our endowment points, let's put it right here. Let's call this point E, and it is at 5,000 this summer, 5,500 next summer. Now, because we can always choose to consume our endowment point and not enter the capital market, point E, our endowment point's always got to be on our budget constraint. Now let's see what happens in the other location. So let's think about how would we get to this, the x-intercept or the C1 intercept. That means that I'm only eating this summer. That means that I'm using up all $5,000 of my income from this summer, plus I'm getting a loan against my 5,500 and I'm transferring it into today's consumption. How do I do that? I get a loan. What's the maximum amount that the bank would loan me on $5,500 in the future? Well, we know that for borrowing right now, the borrowing interest rate is 10%. Okay? And in general, I know whatever I borrow now, I have to pay back at a rate of 1 plus R, or 1.1. So how much will they loan me on my 5,500? So when I pay that back times 1 plus 10%, which is 1.1, it will be $5,500. Well, this kind of makes sense. If they loan me 5,500 over 1 plus R, 1.1, then when I pay this quantity back, I have to pay back what I borrowed plus interest times 1.1. Well, that's going to cross out and it will be exactly $5,500, which is how much I have. So the maximum amount the bank would pay me today is $5,500 divided by 1.1, which is $5,000. So that means that the total amount I could eat now is my $5,000 I'm currently getting paid plus the $5,000 loan the bank would make me. That's $10,000, okay? And I have, my budget constraint looks like that. What's the slope of that? The slope of that is 1 plus R, or 1.1. Alright, now on the flip side, let me ask what would be the maximum amount I would consume next period. Well, next period I'm earning $5,500 plus the amount of money I could put in the bank. So if I put all $5,000 in the bank, then, well, my savings interest rate is 5%. If I put $5,000 into the bank at 1.1% interest rate, I believe I should get, oh, sorry, this is wrong. I only get to put it in the bank for 5% interest, okay? And that's going to be $5,250. So next period, the maximum I could consume is $5,500 plus $5,250 is $10,750. And so I draw this line here. For purposes of making something clear here in a second, I'm going to put this a little bit lower. It's not to scale. Okay, the slope here is 1.05. Okay, and that is part A of this. Now, in part B, what happens? Let me use a different color. The interest rates get turned around. So I have a 5% borrowing and a 10% savings. That means the maximum amount the bank will loan me, I still have the same endowment point, by the way. The maximum amount the bank would loan me is 5,000 divided by 1.05, okay? That's actually going to be a bigger number than 5,000 divided by 1.1. When I add 5,000 divided by 1.05, that's the amount the bank would loan me on tomorrow's or next period's income, plus the $5,000 I have from my income this year. That's going to give me $10,238. So let me extend this axis a little bit. 10,238. And whoops, it cuts right through there. But this is what we have. It's 1.05. Okay. Now you can see it's a smaller, so it's a less steep slope because 1.05 is a smaller number than 1.1. All right, next, what I want to do is do next year's total amount that I could have. Now, next year if I save at 10%, so I put my 5,000 times 1.1, that's how much it's going to be when it comes out of the bank at a 10% savings interest rate, plus 5,000, that's going to equal to 11,000. So 11,000 is going to be up here somewhere, and you can see this is 1.1. Now, you can tell that you're better off in this second scenario. So that was part B. C, a set is defined as convex if the line connecting any 2 points in the set also lies in the set. Is the choice set in part A a convex set? Well, you can see that in part A, it's convex because it's kinked outward like that. And any point you pick in here, it's going to be connected by a line. This other budget constraint, I don't know if you can tell, but it's actually kinked outwards. So these have flung out to the point where it is kinked outwards. Since it's kinked outwards, you could find a point right here, and when you try to connect it to this point here, the line would go outside the set. So it is not convex. Which scenario would you prefer? Well, remember, where is my choice set bigger? The choice set is all the area underneath the budget constraint. My choice set is clearly bigger in scenario B. These interest rates, the red budget constraint on here, and if you think about it, these interest rates are more favorable for you, either if you're the borrower or the saver.